Today we are going to discuss about experiment 3, searching and sorting of 16-bit numbers using MASM. The aim to write an assembly language program to perform the following operation using MASM. First one, to sort given array of 16-bit numbers in ascending order. Second, to search a particular element in a given array of 16-bit numbers and find its position. So here first we perform the operation of sorting a given array of 16-bit numbers in ascending order. Here first step is to print str macro message. Here we want to print a message. Then we use this macro portion to print a message. Whatever parameter we are passing through this MSG, that will be printed. And next another macro is used here is read num. This read num macro is used to read a character from the keyboard, and when we read a character from the keyboard, it is in the format of ASCII and it is converted to hex format for processing. That is done by the macro read num, that is ended here. Then third step is to declare the data's record for our program. That is done inside this data segment portion. Within this data segment portion, we are declare what are the message to be printed, and also we are declare the variables or tables required for our program. Then next we are writing the code, that is here, this code containing sorting procedure. In this sorting, here we are perform a bubble sort. Which sorting method is used here? We are using a bubble sort method. Here first we initialize the data segment. First step of code segment is assume CS as code and DS as data. Then initialize the code segment. Then print the messages, that is the sorting messages, and read the count value. Then how many numbers are to be sorted, that is given in the count. Suppose it is 3. We are store this value in CX register. So CX containing the count. Then we initialize a array tab. Tab is an array and which is loaded with offset address. That offset address is loaded into SI. So SI pointed to that tab. Then we are reading or enter the number. Then here number will be moved to AX register. Then AX register content will be moved to SI. Suppose our content is 0003. Then it will be stored in accumulator as 0300. So that is it requires, it is a 16-bit number, so it requires 2 bytes or 2 memory location to store. So its SI pointer will be incremented by 2. That is here. It is a 16-bit number, so it requires 2 bytes of memory location. So SI will be incremented by twice. and loop next. Loop next means first Cx value will be decremented by 1 and count again, read the next number. If it is 0004, then it will be stored here and SI pointer will be incremented by twice and count again loop indicate in this instruction which executed until Cx value become 0. So next it will be decremented by 1. Then again we read the third number 001. So that will be stored here and INC will be incremented by twice. Now count where Cx value will be 0. Loop will be exited. From the loop it will be exited. So there are 3 numbers are to be sorted. So next we entered 3 numbers. So 03, 04 and 01, that is entered in a table. So next our sorting program will be started here. Count will be assigned to BX register. Now BX register containing count and next decrement BX register. BX register value will be decremented by 1. Now count value will be 3. So 3 will be stored in BX register. Decremented BX means 2. So it perform 2 time iteration. Then BX value will be given to Cx register. So now Cx value will be 2. Then LEA SI comma tab. Again this SI is pointed to initial location of the tab. Then first what will be performed? SI content will be moved to AX. For what is SI content? 003. That is, this will be moved to AX register and increment SI. SI will be incremented by twice. Then compare AX with SI. Now SI pointed to 004, second number. So these two will be compared. So which jump on below. Then AX content is less than, here compare AX SI. Then JB indicate that if AX content is less than BX, SI is now pointed to 004. So if AX content is less than SI, correct ആണ്. AX content 3 ആണ്, SI content is 4. So AX content is less than SI. Then jump to which location? Jump to RP2. So here Cx value is 2, AX content is 0003, SI is 0004, third content is 0001. So here count value will be decremented by 1. Then jump on non-zero reported. Count value is not 0. So എങ്ങോട്ട് jump ചെയ്യണം? Repeat 1. ഇവിടേക്ക് jump ചെയ്യുക. Then now SI content is 004. നമുക്ക് ഇത് ചെറുതാണെങ്കിൽ ഒന്നും ചെയ്യേണ്ട, അതുപോലെ തന്നെ വെച്ചാൽ മതി. എന്ത് ചെയ്താൽ മതി? നെക്സ്റ്റ് ഇത് രണ്ടും നെക്സ്റ്റ് 2 നമ്പേഴ്സിനെ കമ്പയർ ചെയ്യണം. സോ SI കണ്ടൻറ്റ് ഇപ്പോൾ ഏതിലേക്ക് മൂവ് ചെയ്തു? AX രജിസ്റ്ററിലേക്ക് മൂവ് ചെയ്തു. ദാറ്റ് ഈസ് AX കണ്ടെയ്നിങ് 004. Then increment SI pointed to next memory location. Then compare AX with, now SI is here 0001. So AX is compared with SI. So 004 and 001. Then here 000 is not less than, not below the Si content. It is greater than. So this loop is not satisfied. This condition is not satisfied. So what will be take place? XCHG AXSI. That is, exchange the content in AX and Si. So AX content and Si content are exchanged. So AX content is now 004, Si content is 00. That will be exchanged. That is, now its content will be 0001 and Si content will be 0004. Then decrement in this here, it is, suppose here it is 03, 04, 01. Then we are exchanging these two contents, AS content and Si. Now Si content is 001. Then pointer will be here. Si pointer will be here. It will be decremented by 2. That is, it is pointed to this location. And AS content is now is 001. That will be copied into here. And AS and increment Si. Now Si will be incremented to twice, and so Si content is now, here it is 4. Then decrement Cx. Cx value will be decremented by 1, that is 0. Then Cs will be 0. So again we are going to here decrement Bx. Bx is already set there. Bx value is 2. Then it again decremented by 1. So it is value now 1. Then Bx value is non-zero. Here non-zero. Bx value is, now its value is 1. So it is non-zero. So go jump to the location sort. Where is sort? It is move to here. Move to sort. Again Cx value is equal to 1. Copy the Bx value. Bx is now 1 and it is again copied to Cx. Then we are considering the table containing the value now 03, 01, 04. So a tab here, table value is here, then Si here. Again take the first value 03 and that will be stored in AX register. Then pointer will be incremented by 2. Then it point to here. And Si content, this is Si content. And both are compared. Si and AX are compared. If 03 is less than 01, there is no change. Here it is not less than. 03 is greater than, above the Si. So exchange this content. That is 03 is moved to Si. Then Si content will be moved to AX. Then AX will be stored here. 01 will be here and 03 will be stored here. Then again we are comparing this 03 and 04. Then 03 is less than 04. So there is no change is there. And we again change, count value will be decremented by 1, 0. Then we are moved to Bx register. Bx value will be decremented by 1. Its value is now 0. So sorting is not performed. It's already in a sorted order. All data are in a sorted order. So we will print the message. Then next we want to display this sorted array. So for that we are call a function hex to ASCII. Then all the data in this tab will be sorted order and it is in a hexadecimal format. We want to convert into ASCII format before going to display. So we are using a display procedure, that is hex to ASCII procedure. After hex to ASCII, this data will be printed. That's all about sorting procedure. In this sorting procedure, we are using bubble sort method. When we compile this bubble sort program, then we will get the result like this. First we compile, then link that object file, then run the program. When we run the program for sorting, we enter the number of elements is 6 and we entered 6 number and we will get the sorted output.